Good day. I will discuss additional problem solving on the lesson Planes in Space, is specifically equation of a plane. So let's have this first example. Find an equation of the plane that contains the line x equals negative 2 plus 3t, y equals 4 plus 2t, z equals 3 minus t, and is perpendicular to the plane x minus 2y plus z is equal to 5. So let us draw the two planes here so that we can have a better analysis on the problem. So we have here a plane which is an unknown plane and it contains the line. So if this is the plane with a line L on it, and we have another plane which is perpendicular to our first plane, let us call this as plane 1. So if we're going to draw another plane perpendicular to plane 1, let us call this as plane 2. So with the following equation of plane 2, x minus 2y plus z is equal to 5. Then for the other given here, equation of line L, which is on your plane 1, we have the following equation, x equals negative 2 plus 3t, y equals 4 plus 2t, and z is equal to 3 minus t. Now, the unknown plane is plane 1. And in defining the equation of plane 1, we need to find its normal vector. Let us represent this as n1, which is unknown. And then you have a point also, which is point P, which we can obtain by the equation of your line L. So because we have line L on your plane 1, so it means that there's a point P on your line L. And this is the same point P that is needed to define the equation of your plane 1. So for the coordinates of your point P, we can easily identify it from the equation. We have it as negative 2, that is x sub 0, then y sub 0 is 4, then we have z sub 0 is 3. Because if you recall, we have the equation of a line parametric form. We have x equals xo plus at, y equals yo plus bt, then z equals zo plus ct. So therefore, point P will have coordinates negative 4, or rather negative 2, 4, 3. Then we also have a vector on your line L, and this will have coordinates 3 to negative 1. So that is for the coefficients of your parameter t. So we have it as 3 to negative 1. And then we will get also now the normal of your plane 2, and this normal on your plane 2 is perpendicular to your plane 2. And how we're going to graphically represent normal 2. It will be in this manner because it's perpendicular to the second plane or plane 2. So this is now your normal 2. And we can easily identify the components of your normal 2 from the coefficients of the equation of your plane. That is coefficients of x, y, z. So we have it as 1, negative 2, 1. So how are we going to find n1 now? So as you can see, if we have plane 2 is perpendicular to plane 1, And then normal 1 will also be perpendicular to plane 1. And as we can see, we now have also N1 perpendicular to N2. And that we also have, if we're going to extend this N1, we can see that it is also perpendicular to your vector V. So with that, we can define N1 be equal to the cross product of N2 and vector V. So again, why do we say that we have the cross product of N2 and vector V produce N1? Because as you can see, if this is N1 again, and then we have this as our N2, and this is our vector V, you can see that N1 is perpendicular to both N2 and N1, or rather vector V. So with that, if we can get now the cross product of these two vectors N2 and V, that will produce your N1. So then we now form the matrix which we have it as I, J, K as the first row. And the second row will be N2 components. We have 1, negative 2, 1. And then vector V, we have the components 3, 2, negative 1. So which forms a 3 by 3 matrix. And using basket method, we now have to copy the first two columns. So I, 1, 3, then J, negative 2, 2. So with that, we can now perform the other multiplication. So this is now 2I, then plus 3J, then you have plus 2K. Then minus the other side, that's negative 6K. Then we have it as positive 2I. Then we have negative J. So defining now your N1, 2I minus 2I would be, or will be 0, 3J minus J, that will be 3 plus J, that will be 4J. Then lastly, 2K minus 6K, that will be 8K. So plus 8K. So therefore, the components of N1 in bracket form will be 0, 4, 8. And with that, we can now define equation of your plane 1 because we already have the point P, which we have it as negative 2, 4, 3. And defining the equation of your plane using the point normal form, we have A times the quantity X minus X sub 0 plus B times the quantity Y minus Y sub 0 plus C times the quantity Z minus Z sub 0 equals 0. So A here will be 0 times X minus X sub 0, which is negative 2, then plus 4 times Y minus 4, then plus 8 times Z minus 3. So simplifying it, we have now 4Y because this is now 0. So we have 4Y plus 8Z. Then you have negative 16 and negative 24. That will be negative 14. We can reduce this equation having it divisible by 4. So we get now the equation of the plane in reduced form, that is y plus 2z minus 10 is equal to 0. So this is the equation of your plane 1.